This is part 5 of the chemical analysis topic for GCSE AQA chemistry. Please note this is triple chemistry only. Due reward scientists do not need any of this content. As always, I'm going to recommend that you pause as you go and have a go at the activities. So within this particular video, we are going to look at the test for carbonates, halide ions and sulfate ions. So tests for negative ions. Now, similar to the positive ion tests that we looked at in the previous video, you are going to have to remember the methodology, what steps you go through, as well as the observations that you would make. So let's begin with the test for carbonates. Have a think about the question here. And it takes us back to work that's been done previously on acids and alkalis and neutralization reactions, because there are many salt preparations that you need to be familiar with. In this one, an acid and a metal carbonate will react to make salt water, but it will also make carbon dioxide. Now, the actual method that we're going through here, it says here you must wear full goggles because you're using sodium hydroxide. It is corrosive. You will place the substance being tested in a test tube. I'll show you a diagram of that in a moment. And lime water in a boiling tube. And then you're going to add hydrochloric acid to the test tube and start collecting the gas given off. So we've got what we think might be a carbonate. We have got the hydrochloric acid added. We've got this delivery tube going into, you can see the water line there for the lime water. It's going into the lime water, so the gas will bubble through the lime water. We actually saw 2 videos ago in some of the common gas tests that we were using this. We're using the same test. We're just generating the carbon dioxide as part of the test this time. So what would you observe in the lime water in this reaction? The lime water would turn cloudy. What gas is it that causes the lime water to go cloudy? That's carbon dioxide. And just being able to explain this in your own words is important. I'm going to put down one alternative, but it's certainly not the only way to do it. So you can add acid to the sample being tested. You can then collect the gas that's being released, bubble it through lime water, and in the case of a positive result, the lime water will turn cloudy. A couple more questions for you to try here. So I'm doing this for copper carbonate. Copper carbonate, and I'm doing it with hydrochloric acid. And if I do that, my salt would be copper, because of the copper carbonate, and chloride because it's hydrochloric acid, so that would be copper chloride. As we established from the general equation, we're making carbon dioxide and we're making water also. And in terms of the balanced symbol equation for this, well, there's lots of things. You need to know that hydrochloric acid is HCl. You need to know that copper carbonate would be CuCO3, copper chloride CuCl2. So all that's left then is the balancing. And I've got 2 H's here. I've only got 1 H. Let's put a 2 in. That gives me 2 Cl's, which balances the Cl's too. We're done. Though there is more information that we can add here. In case you've missed it, we need state symbols as well. Solid, aqueous, gaseous carbon dioxide. Remember, water will never be aqueous. It's a liquid. Aqueous means dissolved in water. You can't dissolve water in water. And what would we do if we replace the acids or replace the metal carbonates? What observations would we make? All of them would give the same positive result. So let's move on and take a look at the test for halide ions once again. But just to clarify, you need to be able to test for chloride, bromide and iodide ions. We do the same test, but they all have different observations. We add a centimetre depth of nitric acid. That removes any carbonate impurities, and then we add silver nitrate. You need to learn that method. So what observations do we make? Well, in these circumstances, with a chloride ion, we would make a white precipitate. With a bromide ion, we would make a cream precipitate. And with an iodide ion, we would make a yellow precipitate. A few more questions for you to try here. So if it was sodium chloride, we've got an equation to represent what would happen. Which of those is the precipitate? Hopefully what you're looking at is the state symbols. Remember, a precipitate is where you make a solid by reacting solutions. We've made solid AgCl, so that's the precipitate. Ionic equations, we did a lot of work on this a few chapters back, a few videos back. You break up anything that's ionic and aqueous. So I'm going to do all of that just at the top here. My NaCl breaks up, my AgNO3 breaks up, my NaNO3 breaks up, but I'm not breaking up the AgCl. It's ionic, but it's solid, so it stays together. What I can then do is get rid of spectators, things that appear on both sides of the equation unchanged. Well, I've got Na plus going on to be Na plus, so I get rid. I have also got NO3 minus going on to be NO3 minus, so I get rid. And that then leaves me with what's going to remain. Ag plus and Cl minus make AgCl. And you'll notice once again, I've put the state symbols in. Any good ionic equation would include them. So what would the equation be if we had instead done NABR? Well, it's very similar to the one we've got above, so I'm not going to spend ages going through it. If you substitute the Cl's for Brs, we're done. The AgCl solid is a white precipitate. As we already know from the observations, AgBr solid is a cream precipitate. What further test could we do to prove there were sodium ions present? This was discussed in the previous video. We could do a flame test and it would give us a yellow flame. So now let's move on to the final test for negative ions. That's the test for sulfate ions. Again, a method you need to learn. We take a sample of what we want to test, add some hydrochloric acid, that removes excess carbonate impurities, then add a centimetre depth of barium chloride and note your observations. Few questions for you to try. What observation do we make if sulfate ions are present? And it's a white precipitate. And similar to what we looked at earlier on the previous test, which of the products here is going to be that white precipitate? Well, the state symbols give it away. Our BaSO4, barium sulfate, is solid. So BaSO4 is the cause of the precipitate. And another opportunity to do an ionic equation. Break up anything that's aqueous and ionic, and we get this. I've not broken up the BaSO4. It's ionic, but it's solid. I can now start to get rid of spectators. I've got 2K plus on the left, 2K plus on the right, so let's get rid of them. And I have got 2Cl on the left and 2Cl minus, on the left and 2Cl minus on the right, so I get rid of them. And we are left with what goes into the ionic equation. Ba plus 2 plus SO4 2 minus makes BaSO4. And again, I've added the state symbols. Aqueous barium ions, aqueous sulfate ions, solid barium sulfate. My white precipitate formed, proving the presence of sulfate ions. That takes us to the end of this video. Thank you for listening and goodbye.